Time to go through our flame test lab summary. First, lighting the burners.
I'm going to show you the process for lighting a Tirrill burner. Now this is very similar to a Bunsen burner, except a Tirrill burner down here has a gas control. So before I get started, base, gas control, barrel, this is the collar with the air vents, the rubber tubing, and this is connected to the gas control. This is where gas is going to come out of. Okay, before I get started, I'm just going to hold the base, make sure that the barrel is tight, make sure the gas control is tight, but that means I turn it the opposite direction. So clockwise for the barrel to tighten and counterclockwise for the gas. And I'm going to make sure that this is off. Remember, that means it is perpendicular to where the rubber tubing is and the gas comes out. Now I'm ready to get started. Turn on the gas here. It should line up with the rubber tubing. Now gas is flowing through the rubber tubing here, but not coming out because I have not opened the gas valve. Hold the base, turn the gas valve slightly so gas is coming out. Use the striker and light the flame. There we go. This, however, is not the best flame. This, again, looking like this. Okay, this is not the best flame for working in lab. I need to let in more air to make this flame warmer. So start to rotate the barrel, opposite direction, remember? Start turning it. You'll notice the color of the flame. So I'm going to hold this up and rotate. The color of the flame starts to change, but keep going, keep going, keep going, keep going. All right, finally, I see that inner core and outer core. Remember, the top of that inner core would be the hottest part of that flame, okay? So just a little closer. Okay, we can see that inner core and outer core clearly, okay? Looks beautiful, amazing, right? That is how you light the burner. Now, in the next video, I'm going to show you the process for shutting down the burner. Okay, you have finished your lab and you're ready to turn off the burner. What do you do? Okay, go back to the source, follow that rubber tubing all the way back to the beginning and shut off the gas. That should cause your flame to go out. This is the barrel. Remember, this is the collar with the air vents. Rotate the barrel until that is closed. There we go. Now this is the gas control. That's how I know this is a Tirrill burner, not a Bunsen burner. And I'm going to rotate that in order to close it. Remember, that goes counterclockwise, barrel tightens clockwise. Okay, tighten that. And then I am finished with the burner. In lab, you may leave this connected or be asked to disconnect it. You follow that direction.
Which image shows a Tirrill burner? Which one? Yeah, this one. How do I know? Right here. This is the needle valve to control the gas. This is a Bunsen burner. Notice there is no gas control here. So all of the gas coming through the rubber tubing here ends up going up through the barrel. So we can adjust the air, but not the gas in a Bunsen burner. All right, it's time to go over the lab handout. Here is a simple sketch of a Bunsen burner. The burner is lit and ready to use in the lab. Use colored pencils to do the following. 1, color the flame to show the correct colors. So we should have a lighter inner core and a darker and paler outer core. Color the base green. Color the barrel black. And draw red rubber tubing connected in the correct location. It should be connected to the gas inlet. Which number is the arrow pointing to? So yours should be labeled. We're going to go through and make sure you know which is which. So which number is that? Yeah, that's the barrel. Which number would that be? Yeah, that's the collar. Which number would that be? Yep, those are the air vents. Which number would that be? Yep, that's the gas inlet. Which number would that be? Yep, that's the needle valve. And which number would that be? Yeah, that's the base. Okay, circle the gas valve that is closed. Right there. Name this piece of lab equipment. Striker. Draw arrows to show the correct flow of gas between the gas valve and the burner flame. So it's coming out like this, going around, and then going up the burner to the flame. Are goggles required when using a burner? Yes, 1,000%. Where is the hottest part of the Bunsen burner flame? Yeah, the top of the inner core. What is the main difference between a Bunsen burner and a Tirrill burner? Yeah, the Tirrill burner has that gas control valve, the needle valve. When you first light the burner, what color should the flame be? Orange. When you use the burner, what color should the flame be? Yeah, blue. Where should you turn the burner off first? So that's the main gas valve, like all the way connect where we turned it on first and turn it off. That's where we go. Always start and end at the same spot first. Turn the valve so it faces the rubber tubing, and then when I'm ready to turn it off, there first. What part of the burner should you adjust if the flame is too high? Yeah, that's the needle valve. That means too much gas is coming out. What part of the burner should you adjust if the flame is orange? That's the barrel. We need more air. After opening the gas valve, what part of the Tirrill burner should you adjust before trying to light the flame? Well, if we open the gas valve, we're sending gas to the burner, but we didn't let gas come up yet, so we need to adjust the needle valve. Before lighting the burner, so before doing anything, the barrel should be closed. And which way do we turn it? Clockwise. And before lighting the burner, the needle valve should be closed. And we do this by turning the valve counterclockwise. Which part of the Tirrill burner is adjusted to control airflow? The barrel. Which part of the Tirrill burner is adjusted to control gas flow? The needle valve. Why should you check the rubber tubing before lighting the burner? So we want to make sure there are no gas leaks. We don't want the rubber tubing to get disconnected and there to be gas leaking out. All right, so what's actually occurring to make a flame test happen? Well, we have metal atoms that have their electrons in the ground state, meaning the lowest possible energy levels, and we can look those up on the periodic table. Okay? Then we apply heat, so in this case from a Bunsen burner flame, those electrons get excited and they jump up to a higher energy level. Why? Because we gave them energy. So you can see right here, we have ground state. We add energy in, we excite those electrons, and they jump up to a higher energy level. But they don't like to hang out there because they're unstable, that's stressful. So they will fall back down to ground state and in the process emit energy. And that energy we see as light and how many energy levels the electron falls and from which energy level it falls. So is it 2 to 1 or is it 3 to 1 or is it 3 to 2? Okay, so how many energy levels it falls and from which one to which one determines the color that we see. And just as like a quick overview, if it has a lot of energy, it's going to tend toward the violet end of the spectrum. Less energy is going to tend toward the red end of the spectrum. The elements that we're going to use in our flame test are calcium and potassium and sodium. And we're going to pair them with chlorine for each one. So you can see that the difference in colors that we see is not based on the chlorine. It is based on the metal that is paired with the chloride atom. Okay, now let's look at the flame test. So first, we're going to watch the flame test and make sure that our data table is correct. Okay. All right, so here is the flame test for calcium chloride. You can see the chemical formula for calcium chloride there. Okay, and we're going to use the wooden splint, and we're going to make sure that we put it into the hottest part of the flame. And then you are going to see, look at that. Look at the flame color. Okay, now you could see orange. Orange is not specific enough. So how would you describe it? Okay, let's go to the next slide. Okay, so we're going to look at the calcium chloride column first. What was the formula? Well, CaCl2, and that is because calcium, well, first with the next question. Calcium is the metal ion, so it's Ca plus 2. Cl on the periodic table is Cl minus 1. Okay, so that's why we need 2 of them. What is the ground state configuration? Right there. What is one possible excited state? Remember, we have to take one of those electrons and boop, move it up to a higher energy level. Well, we can't change the number of electrons. So calcium has 20, so we have to end with 20, but one has to be higher. So there is a possible excited state electron configuration, but not the only one, a possible one. What color did we see? Well, a dark orange or an orange red. That's what we saw. All right, now let's look at sodium chloride. Okay, and here notice the chemical formula for sodium chloride. Okay, and we're going to get the wooden splint again and tilt the burner just so that we can see it a little better. And we're going to look for what color flame we see. That one is much brighter than the other one, right? That is definitely not the same. All right, so let's go through just the sodium chloride column. What was the chemical formula? NaCl. Which metal ion is present? Well, Na plus 1. And we can write plus 1 or just plus. If we don't write the 1 after the plus sign, it's assumed to be plus 1. What is the ground state? Right there. What is the possible one of a whole bunch of possible excited state? Remember, I just need to take one electron and boop, move it higher. So there is a possibility. Remember, I cannot change the number of electrons. I just need to take one and move it higher. And what was the color of that flame? It was bright orange, or you could say orange yellow, right? All right, and the last one that we looked at is potassium chloride. So look at that chemical formula. And again, we're going to take the wooden splint and put it into the flame near the top of the inner core, the hottest part. And for this one, I'm going to want to look around the outside edges of the flame. My answer is not orange or yellow. I'm looking at the outside edges of the flame. So what do you see when you look there at the outside edges? Okay, so let's go through this one. Did you remember the chemical formula? Okay, KCl. The metal ion present, here we go. Okay, plus 1. What is the ground state configuration? What is one possible excited state? Remember, we're going to take one electron and boop, move it higher. And what color did we see? Lavender or light purple, light pink. Those would all be acceptable. Okay, during a flame test, a lithium salt produces a characteristic red flame. This red color is produced when electrons in excited lithium atoms do what? Well, the flame right? When we put the wooden splint in the flame, the heat causes electrons to be excited, which means they jump up to higher energy levels. And then when they fall back down to ground state, we see light, okay? So when do we see the red color? When electrons return to lower energy states. Number 2. During a flame test, ions of a specific metal are heated in the flame of a gas burner. A characteristic color of light is emitted by these ions in the flame when the electrons. So this is the same question, just worded a little differently. So it's going to be 3, emit energy, give off energy as they return to lower energy levels. Flame tests are used to identify what? Well, remember, all of them had chlorine. So it's not chlorine, it is the metal ions. An excited potassium ion emits a specific amount of energy when one of its electrons moves from. So remember, it emits or gives off the energy when it falls down low. So is 1 to 4 falling lower? No. Is 2 to 4 falling lower? No. Is 4 to 5 falling lower? No. So 4 to 2, yes, that's falling lower. All right, the diagram below represents the bright line spectra of 4 elements and a bright line spectrum produced by an unidentified element. What is the unidentified element? Well, that means the lines have to match up. So let's just change this color. So here is the first line. That has to be present. So I can already get rid of X and Z because they don't have a line here. Okay. Then it needs a line here. Okay, it's close for this one. Let's keep going, right? It needs a line here. Well, that's definitely this one, not here. So it is L. Which elements are present in the mixture seen below? Okay, well here, I can see the mixture has 2 lines right here. There's one element that has those, so I know element X has to be in the mixture, okay? Now let's see, let's look. Here's an interesting thing. This element has a double line here. Does my mixture? Nope. Get rid of D. All right, now I'm going to look right here. Look at this line. Is that present in the mixture? Nope, it's not. So my 2 elements are X and A. All right, what about in this one? Based on the diagram below, each line in the spectra represents what? Energy that is released as an electron moves from higher to lower. Which change occurs when an atom in an excited state returns to the ground state? Energy is emitted. The atoms in a sample of an element are in excited states. A bright line spectrum is produced when these atoms emit energy. A specific amount of energy is emitted when electrons in an atom in a sample of an element return to the ground state. This emitted energy can be used to determine, it's like a fingerprint, the identity of the element. An atom of oxygen is in the excited state. When an electron in this atom moves from the 3rd shell to the 2nd shell, energy is emitted by the electron, right? Be careful, not the nucleus. Which energy change occurs during the burning of a salt in a flame test? We use chemical energy to produce light energy. We see light with our eyeballs, right? And that came from the chemical energy inside the atom. Which electron configuration represents the electrons of an atom in the excited state? Here's what you should remember. If it's on the periodic table, it is ground state. So I just start looking. Do I see this one on the periodic table? Well, not at first glance. Do I see this one? Yep, ground state. Do I see this one? Yep, ground state. Do I see this one? Yep, ground state. So that means this one right here is not on the periodic table, so it must be the excited state. Which electron configuration represents the distribution of electrons in a potassium atom in the ground state? What does that mean? You just literally look it up on the periodic table. Bing, right there. Which electron configuration represents the electrons of a phosphorus atom in an excited state? So first what I need to know is the electron configuration of phosphorus in the ground state, because that's going to be a wrong answer, okay? So phosphorus in the ground state is this one right here. So that's how many electrons? 15. So what has to happen is I have to still have 15 electrons. One electron has to be higher. So which one is that? Yeah, there we go. Which electron configuration represents the electrons in an atom of sodium in the ground state at STP? Ground state, what do? Look at the periodic table, find it. That's the answer. And there we go. That's number 2. All right, now your lab handout should be complete and correct, and you are ready to submit it.